I'm really excited to announce that from January 2023, I'll be able to further support you with small group tutoring, intensive revision courses in the holidays, or online tutoring too. So if you find the way that I describe things useful and you'd like some extra help, then please get in touch via my website, www.cardiff-maths-tutor.co.uk. Also, if you could hit the subscribe button, that'd really help me continue to make these free videos. Thank you. This is Mr. Ashton going through the Mathematics Unit 2 Calculator Allowed higher tier paper from November 2019. Now, I have done the intermediate paper already, so if you look at the link below, there's a chance to go and see the first 9 questions. I'm going to jump straight into the first question that was higher tier only, okay? So second page, as always, is the formula list, so we may use these, probably likely to use this, maybe even this on a calculator paper, possibly this, okay? First one says, absolutely no need to use a calculator for this either. It says, simplify then factorise the following expression. So I need to expand out this bracket here. We're going to get 9k times by k, so 9k squared then. K times by minus 1, minus k. Then we have a plus k, then we have a minus 25n squared, okay? 3 marks, just picked up one of them. I can see there that those k's will cancel, minus k add k goes to 0. But I am left with 9k squared minus 25n squared. Now, I obviously haven't done enough work to get all those 3 marks, so you need to be looking at that and thinking, well, what on earth is going on here? And hopefully you're noticing that I have a square number and a square number. Obviously, k squared is squared, as is n. So this is what we call the difference of 2 squares. The difference of 2 squares. So in order to answer this question, what we would do is we would square root the 9, but we'd actually do what I just said. We would square root the 9 to get 3 and square root the k squared to get k. In one of the brackets you'll have add, square root of 25 is 5 and n. And then in the other bracket you'd have exactly the same thing, but you notice here that I'll have a minus 5n. That would generate the 9k squared, the minus 25n squared, and then it would also generate a plus 15nk, but then a minus 15nk as well, which would cancel out, okay? So the difference of 2 squares is what this is called. Over the page, it says the area of a trapezium is 25 centimetres squared. Then it goes and puts in all these measurements here, and it says show that 2x squared plus 3x minus 50 equals 0. Well, that means I'm going to use this formula here, where I look at the parallel sides and I times by the height. So literally exactly the same format as the formula sheet here. Lovely. So we're going to say a half of the parallel side, so x plus 1 plus x plus 2 times by the height, so times by x, is equal to the area, is equal to 25. Okay. First thing I'm going to do, BIDMAS, do the brackets. So I'm going to get a half of x. In fact, actually, let's actually answer what that is. X plus x is 2x. So let's squeeze that in there. Plus 1 plus 2 is plus 3. Times that by x equals 25. Okay, well, starting to look at that, I can see a 2x, I can see a 3. That's looking good. I can see an x that I'm going to expand in a second. I don't know why this half. I don't want to do half 2. Half of 2 is x, that's fine, but I don't want half 3. That's going to give me a decimal. So what I'm going to do is times both sides by 2 to get 2x plus 3 times by x equals 50. Okay, now it's really starting to resemble that. That x is going to times both of these things in the bracket, so I'm going to get 2x squared plus 3x equals 50. And you can see in the question then, it says equals 0, so they've taken 50 from each side. So that 2x squared plus 3x is fine there. And then we take away the 50 there. Okay. The next thing says, solve the equation 2x squared plus 3x minus 50 equals 0 to find these lengths. I'm just going to block a bit of the sun out because it's coming through and absolutely brightening all of the work there. So just bear with for a second. There we go. That's a bit better. Okay. There we go. Okay. Hopefully not too dark now. Now you'll notice here that has been asked to solve to 1 decimal place. So ordinarily when we're looking at a quadratic we think, oh, we'll factorise that. No chance of it's asking you to do it as specific as 1 decimal place. Bear in mind we're on the calculator paper. It's going to be time to go and use this thing here. Okay, the quadratic formula. Okay, so the quadratic formula from page 2 states that minus b plus or minus the square root of b squared minus 4ac all over 2a. But I need to know what a, b and c are. Well, a, as we can see at the front here, is the number in front of the a squared. So that's going to be 2. B is the number in front of the x, so 3, and then C is the number at the end. Now be very careful, you have to include that minus. Okay, we're then going to get minus B, minus 3, plus minus, we'll come to that in a second. 3 squared, minus 4 times by A times by C. Okay, all over 2 times by A. Once we're going to add that square root, and once we're going to take away to find my two different solutions for x. So x is either going to be, so grabbing the calculator now. Let's make sure you can see that. I might just turn on the light on my visualizer. Okay, hopefully you can see that coming through now. Fraction button hit first. Minus 3. I'm going to do the plus first. Square root of 3 squared. Should put that in brackets. 3 squared. Minus 4. 2 minus 50, close your brackets. Move down to the bottom, over 2, lots of 2. Press equals, and I get math error. Why? What have I done wrong? It should have said plus 2 lots of minus 50, that's all fine. So what have I done wrong? Something's definitely gone wrong because it gave math error, but I can't see what it is. Right, if that ever happens to you, the best thing to do is hit AC and stick it in again. Minus 3 plus square root of 3 squared. Minus 4, lots of 2, lots of minus 50. I think I had plus before, that might have been the problem. 2 brackets 2, and I press equals and I get a solution this time, which is 4.3 to 1 decimal place. That's when I added that square root. Now I need to just change that, so hit the replay button, delete the first, go to the first couple of lines, delete the plus, change it to a minus, and I get minus 5.8 to 1 dp. Now I've got to choose which one of those solutions it is. Well, x is a height. Well, in that case then, it must be that it's the positive. It must be this answer. Because I can't have a height of minus 5.8. So this is the answer for x. So to work out what AB is that top length there, so it's x plus 1. So it's just going to be 5.3. And to work out DC, that's that bottom length there. So it's going to be x plus 2, so it's going to be 6.3. Okay? Over the page, we are told that a rhombus has an area of 36.8 centimetres squared. The rhombus enlarged by a scale factor of 7. Calculate the area of the enlarged rhombus. Now this is requiring you to know the following. For a line, we do the small line times by the scale factor gives me the big line. If it's area, you do the small times by the scale factor squared, that will give you the big one. And if you're doing volume, you get the small, you times it by the scale factor cubed, and you get the big one. Okay? Now this has told me that the rhombus has an area of that and a scale factor of that. Therefore, we want to do that one. Because we're trying to find the big one, we want to do 36.8 times by 7 squared, and that just goes into our calculator. So 36.8 times 7 squared is 1,803.2 centimetres squared. Next one. The diagram shows the sector of a circle with centre O and radius 7. So I'm going to go and pop on those radii there, 7 and 7. Calculate the perimeter of the section. So I want to know the entire distance around that shape. So if I start there, come down here, I'll do 7, add 7, but then I've got to know that curved bit, okay? Now this is called the arc of a circle, and to work out the arc of a circle, you want to do the angle you have at the centre. So some teachers use theta, others use x over 360, whichever one you prefer, and then you multiply it by the distance around a circle is the circumference, and the formula you can use for that is either 2 pi r, or you could have used pi d as well also. Okay, so in order to work out what this AB is, so arc AB is going to be 42 degrees, so 42 over 360 times by 2 pi times by 7, which is the radius. So I use that because we were told the radius, otherwise I would have just said pi times by 14, which would obviously give me the same answer. That goes into my calculator and I get the answer. 42 over 360 times by 2 pi 7, and then estimate it gives me it's 5.1 to 1 dp. So this is 5.1. So therefore the perimeter would be equal to 7 add 7 add 5.1. 7 add 7 add 5.1 is 19.1 centimetres. Okay then, over the page, have a quick look at the question. I'll join you in about 20 seconds, if not slightly less. Okay, this one is asking for the single transformation that transforms shape A onto shape B. There are 4 types of transformations. Number 1, you have a reflection. Does it look like it's looking back at itself? Number 2, rotation. Does it look like it's been spun around? Number 3, enlargement. Does it look like it's got bigger? And then number 4, which I can't fit in there, so I'll write by here, translation. Does it look exactly the same? It's just been picked up and popped somewhere else. Okay. Now I can go and immediately say it's not a translation. It doesn't look exactly the same. It doesn't look like I picked that up and dropped it there. It's completely changed. Okay, so it's not a translation. Is it a reflection? Well, it's not the same size, so it can't be a reflection. Okay, it does sort of look like it's looking back at itself, but it's got bigger. Okay, so it's not a reflection. Rotation, does it look like it's been spun around? Well, yeah, it does look like it's been spun around, but it's got bigger, so it can't be a rotation. The fact that I keep on saying it's got bigger tells me that it must be enlargement. This could get something smaller. For instance, if I made something half as big, then it would be smaller, wouldn't it? Okay. Now, if this is in a higher tier paper and it is after the staples, after the middle of the paper, there is only one type of question that this can be, and that will be that it is a negative scale factor enlargement. Okay. So use a little bit of knowledge. Normally this would be the first couple of questions. Okay, usually it's quite an easy type of question to do. Not in this case. Okay, this is quite a challenging question. What you're looking to do is try and match up where the same lengths are from, where the same corners are of the shape. And I can see that these ones are actually touching. So those corners there where the right angles are touching. This one here, I'm going to say is that one over there. And then this one here, the height is this one here. Now, usually what you need to do is go and connect all of those and they cross in a place and that's your centre of enlargement. But the fact they're touching already tells me what the centre of enlargement is, okay? The centre of enlargement is where those two touch there. So that is 4, 4, okay? So I'm going to start by getting 1 mark for stating it's an enlargement. I'm next going to get my next mark for saying centre at 4, 4. That's my second mark. How do I get my third mark then? Well, to do that, to get shape A onto shape B, go and pick a side that is equivalent on the other side, okay? So I'm going to choose the height there and then this height here, okay? Now I can see that the original one of A is 3 long. So I'm going to say scale factor equals, 3 by there, and then here it's 6, okay? So it's the new length divided by the old length tells me what the scale factor is, but the fact it's gone in the opposite direction tells me that has to be a minus, okay? So the scale factor would be -2 in this case. It's got 2 times bigger, but rather than going down 2, rather than going down 3 and then make it 6 there, it's gone the opposite direction, so that's why the minus has come in. Okay then, over the page. We're given some letters there. We've got 3, then 4, then 5. So that's going to be 3, 7, 12. There's 12 letters there. Might be useful in a second. It says 3 cards are chosen at random from the box at the same time, i.e. they're not replaced. Okay, that's what that's telling me, not replaced. Calculate the probability that all 3 cards are drawn with the letter C. So I'm looking for the probability of getting C, then C, then C. Chance of me getting C the first time was 3 out of 12. Times by get another one. There's 1 less C, I've got it in my hand. 2 out of 11. Times it by 1 out of 10. Now that can just go straight into your calculator. You do not need to do that off the top of your head. You can do, it's not the hardest one to do in the world. However, you could get it wrong and therefore you could lose marks. So it's a good idea just to run it through your calculator anyway. And we get the answer is 1 over 220. Underneath, the letters A, E and O are vowels. All the other letters on these cards are consonants, so there are only 3 vowels. And if you check them there, A, E and O, there's only 3 vowels there. Okay? Calculate the probability that the 3 cards include at least 1 consonant and at least 1 vowel. Okay? So at least 1 consonant, at least 1 vowel. What I'm going to do is start to do some probability trees. So, vowel or consonant. Second pick, vowel or consonant, vowel or consonant. And then a third pick. I don't particularly like doing probability trees when they get this big, but that's the only thing we can do here, unfortunately. Okay, so eventually we're going to have something like that. Okay, now And before I start writing out probabilities on these trees here, we're quite far through the paper now. We're on page 18, okay? Question 14, very near the end. There's probably an easier way than starting to stick on all of the probabilities. So let's just double check what we're interested in here. We want to have at least one consonant and at least one vowel. Okay, well, let's look at the options that then follow that. So vowel, vowel, vowel. That only got me vowels, so not interested in that. Vowel, vowel, consonant, yes. Yes, 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 no. Okay, there's only two options here that don't work, which is getting all vowels or all consonants. Otherwise, I get at least one of each. Okay, so what I'm going to do is work out the probability of getting vowel, vowel, vowel. And that's actually the same as getting CCC because there's only three vowels. So it's going to be 3 over 12 times by 2 over 11 times by 1 over 10, which we already know is 1 over 220. We're now going to work out the probability of getting consonant, consonant, consonant. So if there are 3 vowels and there are 12 letters in total, then there must be 9 consonants. So 9 out of 12 times by 8 out of 11 times by 7 out of 10. So that's going to go into my calculator. Notice I'm just going to use the replay button to change just the numerators there. And I get it's 21 out of 55. 21 out of 55. Now running a little bit out of space here, I have to come underneath here. If this was you running out of space in your exam, just go and say continued on additional paper. So if you look at the back of your paper here somewhere, you should have some extra paper there. Okay, so make sure you just say what you're working on there, because you don't want to not get it marked by writing outside of the box, but I want to try and keep everything on one page so you can see it easily. So rather than working out all of these ones here, I've worked out these two here. Now I should know that all of these probabilities are going to add to 1. Okay, they're going to add to 1. So what I'm going to do is do 1, take away the 2 probabilities that don't work. So I'm going to do 1 over 220, add 21 over 55, and that's going to go into my calculator, okay? So 1 take away, so you can see my calculator, 1 take away, fraction 1 over 220 plus 21 over 55. Close your brackets, equals 27 over 44. That's probability of getting at least one of each. Okay, question 19, nearly getting near the end here, which is great. Nearly, yeah, we've got a couple of questions to go. I think 3 in total, one being transformations of graphs, okay? Okay then, make A the subject. That means get A all on one side, certainly don't have it as a denominator. So the first thing I'm going to do is times both sides by A squared B. That's going to leave me with 2A squared minus B here. 1 times by A squared B is just going to be A squared B. The next thing I want to do is get A's on one side, everything else on the other. So the first thing I'm going to do is take A squared B off each side, which is going to give me 2A squared minus B minus A squared B equals nothing. There's nothing left on that side, I'm just taking it off. The next thing I'm going to do is get rid of this minus B that's on this side because it hasn't got A in it. And it leaves me with things now that only have A in it. So that equals B. Okay? The next thing I'm going to do is take A squared out as a factor because it's in both bits. So I'm going to get 2 minus B equals B. Next thing I'm going to do is divide both sides by that bracket. So I'm going to get B over 2 minus B. The very final thing I'm going to do is I'm going to square root both sides. So square root in that side gets rid of the square root, and then this square root needs to go over the numerator and the denominator. It's going to be B over 2 minus B. Okay, question 16. This is what is called your transformations of graphs. These are the rules that I have in my head. If it is outside, it does the expected to y. If it is inside, it does the opposite of expected to x. Okay, that works for nearly all of them, bar the minuses. I'll cover the minuses in a second. Okay, so we originally have this graph here, and you can see here it says the equation f of 2x has become that. Why? Well, it's inside the brackets, so I'd expect to times that by 2. However, can you see that 4 there has changed to 2 there, and it just squidged it up. Okay, so it does the opposite of what is expected to x. So what I need to do when I see this one here, see this one here, here's the original graph, this one now has come underneath. Now, lo and behold, it's the only case that I haven't described. The next thing I'm going to do is just draw a very quick graph of x squared. Now you should know what that looks like. Well, turns out not even I do. X squared looks like that, okay? I was getting ready for the next bit. You should also know what minus x squared looks like. Minus x squared is a reflection in the x-axis. Now can you see here that that graph there has just been reflected to be underneath? So this will be a minus whatever that graph was. You see that minus there is inside. That's going to reflect in the y-axis. It'll be a minus outside. So this would be minus f of x there. Okay. The next one here, that looks to me like it is exactly the same graph as that. However, it's just been shifted down one. Okay. So that has affected the y coordinate. It's now no longer there, it's gone down one. So this is going to be the graph of f of x, and then I've moved it down from 1 to 0, so take away 1. So that should be an option there. Yes, that one there, okay? So we've used those two so far. Now this one here, again, it's the y values that have changed. It's still going from 0 to 4, so x hasn't changed, so this is going to be outside the bracket. Now this value has changed from being 1 to being 2. So that's got twice as big. So this would be the graph of 2 times by f of x. So that should be an option there, and that's my option. Okay, so that was your transformations of graphs. Okay then, final question. Final question says, calculate the shaded region of this thing up here. Now we're told that this is a square, so I know this side is equal to this side, and so on and so on and so on. And then I've obviously got a triangle in there. Now I know that DE is 8 centimetres and I know that EC is 9 centimetres, okay? Now what I like to do to try and answer questions like this is I start by just trying to get a worded formula out to think, right, what am I actually doing here? So I'm going to start by saying shaded is equal to the entire square, but that would be all of the square. I want to get rid of the triangle, okay? Now we're told a formula for working out the area of a triangle here. Area of a triangle, bear in mind we're on the last question now, so I imagine it's going to be a tricky one, is a half of AB sine C. So if you look where A and B meet, they meet at C. It's two sides together at an angle, and that's exactly what we've got up here. So we can go and work out the triangle, no problem at all. Okay? That's fine. However, we don't know what the base is. Now, I need to go and work out what this is. Okay, so I'll just say question mark. In fact, actually even better, if that's capital E, this is little e. Okay? Bear in mind this is the last question, it's using triangles, so it's going to be using either sine or cosine rule. You need to know that when you're using the sine rule, at the end of the question, you'll know two sides, two angles, whereas when you're doing the cosine rule, you'll know all three sides and one angle. Here I've got two sides, I want to know a third side, and I know an angle, so it's going to be the cosine rule. Now notice here, capital A, little a, other letters there and there. So because I've got capital E and I want to find little e, I'm going to say length of a square, just so it's clear what I'm doing, length of square. I'm going to do little e squared equals, this would be D, this would be C. Okay, the capital letter is the little letter opposite. And that is going to be D squared plus C squared minus 2DC cos E. So that's me using that formula, but just change it with the letters I have in this question, okay? Alternatively, if you really wanted to, you could go and cross out and put that as A, change that to B, and then just use it using the same letters as the formula. It wouldn't really matter. So now I'm going to start substituting in. I don't know what little e is, so that's going to say it's little e squared. Then it's going to be 9 squared plus 8 squared minus 2 lots of 9 times 8 times by cos 75. That line's just going to go into a calculator for me, okay? I'm not going to do anything like that in my head, okay? So 9 squared plus 8 squared minus 2 lots of 9 times by 8 and then times by cos 75. So just what I've written there goes into the calculator, I press equals, and I get quite a big number. That's e squared. I need to find out what e is, so I will square root that number. So square rooting that answer, I get it 10.37 blah blah blah. Okay, so I now know what the base of that is, 10.37 blah blah blah. That means that's 10.37 blah blah blah. Well, now I know what the area of the square is. The area of the square is going to be that times by that. Okay, so I just want to put in answer squared, and I now know what the area of the square is. So the square is equal to 10.37 times by 10.37. The area of that square is, back to what we had before. That squared number up there, 107.7300575. Now you'll notice I haven't rounded that, and that's because I haven't finished the question, okay? You'll round your very final answer. I now need to go and work out what the triangle is. So that is going to be a half of the two sides that meet at the angle. So a half of 8 times 9 times sine 75, okay? So I'm then going to say 0.5 or a half, doesn't matter which one you do. 8 times 9 times sine 75. Close that there and I get that answer, so I'll SD it to get 34.77 blah 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 centimetres squared. Finally, to work out what the shaded must be then, I want to do that long answer there, that 107 answer, 107.7300575, take away, and half of you will think, what's he done? He didn't write down the full thing, so he can't keep it really accurate. But that's what my calculator has as its previous answer, so I'm going to say take away ands there. I press equals and find out that it is 73.0 centimetres squared to 1 decimal place. And that was the very last question on the paper. I hope you found that useful. If there's anything that I can do to help you, please get in touch. As you know from the intro on the video, I'm now available for some face-to-face or online tutoring if you found this video useful. So thank you very much for watching.